there's nothing complex about aligning your mirrors if you have the right tools to do it. And these little discs are a very important tool to you. Now then, in through there, I think you can see, hang on, I'll zoom you in a bit so you can see. In through the far side over here, you can see a little silver thing there. That is the actual end of the laser itself, and this is number 1 mirror. Back over here, this area here is his number 2 mirror. So what we're going to do, we're going to get this, oh, where are you? We're going to get this, and first of all I'm going to put it on the number 2 mirror in here. And it fits exactly in. All I'm using is a little tiny bit of masking tape, and you just need to stick it on the very top there like that. And if you look through here, just put it into on the mirror there like that, and that's all you need. That's all you need to tell exactly where that laser is striking those mirrors. So that's what we're going to do right now. Right, I'm now going to describe to you how to set this controller to do a pulse, a laser pulse, to fire the beam at a measured level to target those pieces of paper. Now, simply you get this out, either this one or this one, and this will move this select box around in this this area here, like so. Okay, so minimum power level, we want about 30 is fine. Maximum, same. Okay, so now we are set to send a 30% now. 30% is about, oh, let me see, I did measure it. It's about 45 watts at that target, so that's what we're going to do now. Okay, so there's the end of the laser, and now we're going to fire at it just by pressing the laser button here. I'm just going to press it a couple of times, and that's enough. Just a couple of milliseconds like that. I did 2 pulses. So now we'll take that target off and see exactly where it's hitting. Okay, so I've taken that target off, and just to make sure that there's nothing on the mirrors, I'm just going to give them a bit of a clean with some lens cleaner. You sort of got to be fairly gentle with this. These are actually metal mirrors. They're not glass at all. Okay, I think that's pretty clean there now. It looks to be pretty clean for me. Right, so this is mirror number 2 now. So pulse the laser. That's enough. That's all it takes. Just 2 little millisecond pulses and we're done. Okay, and number 3 mirror is of course in here. This is the one that takes the beam 90 degrees, or turns the beam 90 degrees. So just put that over there. Just rub my grubby finger around that. Stay there. That's the actual hole there, like that. So I will give that a pulse. Aha! There's the problem child. See how far off center it is? Okay, so here's the result. Now you can see the beam is coming out of the end of the laser, hitting mirror number 1. It's not bad. Center is about there. It's within what, a millimeter? That's pretty well okay. But this one is often up to one side, and this one is up in this top corner. So we have to adjust this mirror to line up with this mirror first, and then we adjust this mirror to line up with this target here, because what's happening is the beam itself isn't just this wide. Now if you remember the Gaussian shape, now this is just the tip of it. The actual beam is about yay big. So we're clipping, we're missing some off here. Maybe a little bit here too, because what I'm getting out of this mirror is a 10 watt loss, or 10% loss at 100 watts. So I'm only getting 90 watts out of the face. So these mirrors being out of line is probably the reason. So we'll do something about that now. Righto, now here we are at the back of the machine where the laser is housed. Now there's the first mirror, this is the end of the laser. Incidentally, a lot of people have said to me, oh, how do you know if someone's been overdriving the laser? Well, there'll be a chemical difference inside here, and the end of this, where you see this this coppery sort of thing, that will turn dark brown if you overuse the laser, or if you overdrive it. And so there's several different ways in which Recce actually will hold the warranty for these. We don't. So this is the laser, and we have not infinite, but you can adjust the laser in yaw and up and down and any which way you want to. Now we supply all the tools necessary to adjust everything on the machine. So we supply you a set of Allen keys. There's 2 Allen screws back here which act as clamps, and there's an adjusting wheel here to raise the laser up and down. So that's what we're going to do now. We're going to lift the laser up 1 millimeter. I'll try and allow you to see what I'm doing. I'll just slacken these off. And now there's a little milled plastic wheel here that we can adjust. Now I can tell that's gone up approximately a millimetre. I got a bit of a registry here, a little bit more perhaps, and that's it there. So it's just a matter of nipping this back up and we should be fine. A little bit tricky to get to this back one, but you can actually look down through the laser, and I think there, that's done it. Okay, so now let's test it. Now we've altered it. Okay, this should be pretty okay. That's enough. Okay. So there's the new target from mirror number 1. Mirror number 1 was there, and we've moved it up approximately a millimetre. Let's just check. This is a 23. So the centre of that is what, 21? It's about 21, 21 and a half, which is, you know, I think that's good enough. So now we've got to check and do the same with these two mirrors. Slightly different with these, but we'll do that now. Okay, this is mirror number 2 now, and pulse. Now then, our engineers have actually thought of everything to make servicing a laser, for you to service the laser, very easy. We've got doors that are detachable, like so. So you can easily adjust the mirrors in here. This is the second mirror. Third mirror, which is on the end of the laser, that needs to be a little bit more secure. So we made it so you purposely have to remove a panel. So in other words, you know you're entering into a danger position. Oop. And if you see the thickness of that steel, 16 gauge steel plate, is quite heavy. The whole machine is made of that, so it's stable. Okay, so here is mirror number 1 that you can adjust. Now, you don't have to move it very far. So it's just very, very small adjustments, and it's pretty obvious what they are here. The two at the bottom here move the mirror out and in, and the one at the top here moves it out and in that way. If you adjust these together, it will rotate the mirror this way. If you move this one on its own, it will move it that way. So you have a gimbal effect, and we have that on these number 1 and number 2. So we will adjust this mirror now to line up perfectly with that one. We hope. Okay, now I've adjusted it. I'll just show you what I did. Now, let's zoom back out. Okay, so that was the first one I did after. That was the first one I did after I adjusted the laser up, and you can see I took it further up into that top corner. So adjusting the, oh, there we go. Adjusting the beam. Now, it's my advice, just turn the adjusters a quarter of a turn at a time. Oh, let's get the focus right on that. There you go. So what I actually did, I walked in on it That was the first pulse after I adjusted and found, oh, I've gone too much, and I did half a turn. So then I came over to this point, and that was a quarter of a turn back. Then I adjusted the beam down. So I'm just going to check it now to see if it is actually right. Okay, here we go. Oh, and I think that's pretty well in the center. Let's take you back out. Okay, so here we are, mirror number 2. So that's what it originally was. Then we adjusted this one over, or actually up slightly. And that was the test after adjusting the laser up itself. Then I adjusted it over and it went over to here. And that was 1/2 turn of the bottom adjuster. So I adjusted it back and then brought it down, and that's the end result. And I'm going to leave it there. I mean, that's a lot better to what this originally was. So I think we can leave that one there just fine. The telling of it will be at the third mirror. The entrance to the third mirror will tell all. Okay, I found actually it's better just to put a bit of tape over the entrance hole here, and just rub my grubby finger around it to give it a bit of a mark. Actually, you will know before. Oh no, I can just about see. Now here we go. Oh, too low. Way too low. So we're going to walk this mirror up now. What I mean is we're going to adjust it a little bit at a time. Right, I think finally we're pretty well there. Let's maybe down very, very slightly. Very, very slightly. Down, down. That's the 2 bottom ones I adjusted then. One more on this side, I think. Oh, too much. We'll get it in a minute. Now you've heard the phrase spot on, haven't you? Well, I think this applies, because that is exactly where we want it. We want it slightly lower of the center mark. There's a good reason for that. The mirror in here, even though it's a perfect circle, it's lying on a 45-degree angle, as indeed the others are too, and it resembles a cat's eye. So it's the laser beam actually sees that as an oval, if you can imagine it. And it's preferable to have the beam on the just slightly low on center height. And I just want to put a pulse through now. The laser will be defocused down to the bottom there. I better fetch the camera around so you see what I'm doing. A slight word of caution here. Do not run the machine with these panels off. Definitely do not have children around when you have these panels off and you are testing the laser and adjusting the mirrors, or pets for that matter. I cannot stress strongly enough that you need to take great caution when you have a laser and you're using it. These are definitely not a toy. Okay, the last job to do when you finish adjusting all the mirrors, and that is to clean. I don't know whether you can pick that up, because that was the smoke going onto the mirror there and smoking it up. Now before I put the watts meter in between the beam, I just want to show you a little bit about how the beam is focused. Now I've got this piece of material set at the correct distance, which is 9.5 millimeters from the end of the tip of this, which is automatically set with the Z height setting, shall we say, tool. It's got a proximity sensor at the back here, and we're going to what I'm going to do is I'm going to put it on 90% power, which is 100 watts, and we're going to just do a pulse at this piece of wood, and I'll show you the result of the beam going out of focus as we take the table down. And we're going to do tests at 9.5 millimeter, 20 millimeter, 50, 100 and 150 millimeters, and you'll see how the beam goes out of focus. But it is even 150 millimeters away, which is about 4, 5, 6 inches away from the end of the nozzle. It's still a very, very powerful beam. So here we go. I'll fetch you in a bit closer. Here we go at 9.5 with just one pulse. Okay, now we're going to take the Z down 20 millimeters. On a pulse. So it's only a quarter of a second. And the next one. Down. $50. Laser on. Now 100. Set down. It's 100. Now 150. Even at 150 millimeter, that laser will absolutely burn through that wood. I actually just noticed that was a bit out of camera there, so I'll do it in reverse. So this is 150. So you can see that that would actually burn right through that. No trouble at all. Okay, let's fetch it up. To 100. There we go. And fetch it up again. 150. Okay, so there's an example of the beam going in and out of focus. Okay, so here's an example of, now the beam's at 100%, or the laser at 100%. This is about a half-second pulse. There, and there, but then I left it on a bit longer for here and here with about a 2-second. This is about a 5-second pulse, and this is 150 millimeter, which is 6 inches away from, you know, sort of the end of the nozzle, which is way out of focus, but you can see that it's about half an inch, something like that. Hang on, I get a rule. Yeah, there's the actual beam there. You can detect the roundness, and the center of the beam is the hottest or the most powerful. So it's about it's actually 13 and a half, something like that. And of course, as you get closer to the nozzle, it gets more in focus, and and this was in focus, but on a longer period of time. And it actually, well, burnt right through. You can see there it burnt right through, as indeed it burnt right through here. No, that's a mark in the wood. So yeah, it burnt right through there, but just on a half second. So there you go. Just thought you'd like to see that before I put the Mahoney or the watts meter and start checking that out. I just wanted you to understand that the beam's going out of focus, and what I normally do is I have a scrap piece of material underneath down here. Okay, now this is a Mahoney meter I've shown you earlier, I think, in this video. Now to adjust it, there's a nut on the back, and you just adjust it so it reads 0, and this is the ambient temperature in the workshop here. Okay, now I just want to show you something before I run this test. Just to show you that there is a beam here. Okay, never ever put your fingers in between the mirrors, because this will happen. I've made myself clear. It's an invisible beam. So here we go with the test. This is 50 watts now, and let's just see what the actual reading is going to be. Now there's going to be a period of 10 seconds and you'll see the head move slightly, and then it will go into a period of beam on, which is 30 seconds. Then there's another 20 seconds to wait for all the energy to go into this. And I'll show you the meter as it's going. I don't think you'll be able to see the meter very much, but I'll show you it when the beam is finished. But here we go. Right, so it's 10 seconds now, which gives me time to get in any position. Now it's beam on. All the beam energy now is going into that block. Okay, that's the end. So you can see that coming up now. So we've actually got 60, what's that, 65, 66, 67, 68, 69. Is that 69? Yeah, that's 69. I don't think it's going to go any further. That's about it. So at 50%, we've got 69 watts here. Now I can tell you I've had a 6 watt improvement. So the problem I had with the mirrors being out of line, I've solved that. So this is a 100 watt tube, and at 50 watts we got 69, sorry, at 50% we have 69 watts. So remember that graph that isn't linear. Remember in the beginning of this video I showed you, well, this is the reason why. I also found out that 90% output on the computer, if you set it at 90%, it's 100 watts output at the laser end. So now you understand, well, when I was trying to explain to you about the non-linearity of the actual laser output in relation to the percentage input from the program. So at 50% of the program output of power relates to 69 watts here. So you know we're going to get 1 to 2% loss through those two mirrors. So there, maybe you can understand now a little clearer that it's not linear, and you cannot run these lasers, or any lasers for that matter, at 100% output on the program, because it doesn't relate to what is coming out of the laser. I think the next video, what I will do, or between now and the next video, I will conduct a comprehensive testing, and I will show you in a graph form exactly what this actual 100 watt tube puts out per every 5%, something like that of the program. So, but we know that we got from between 10% of the program output to 90% of the program output. That's a big range that we can use. So I hope you've enjoyed this laser beam alignment and cleaning of mirrors and general servicing of a laser. If you have, please press like, and please pop along and see one of my other videos on one of my 2 channels now, either the Australian Inventors Laser Lab or the Australian Inventors Workshop, where there's CNC routers and lathes, wood lathes, and different shop jobs that I do around here. Incidentally, all the machinery that you see in this workshop, like the laser, the CNC routers and the lathes, are actually made in our factories. So I'll leave an email address to get in contact directly with the main office if you're interested. So thank you for watching, and please pop in again. So it's bye for now.